All right, so continuation of volumes by CrossSection. So this is Monday the 26th. So it's still sort of day 2 of nodes, but it's day 2, part 2. So is that really day 3? I don't know. Whatever. We're picking up where we left off at number 5. And this might even be an old AP question, because this is what they look like when they show up on the free response test, or the free response portion. Let S be the region first quadrant bounded, so we're in the first quadrant, by y equals x squared and y equals 4. Okay, y equals x squared, y equals 4. Again, I don't need a calculator to know which one is which for that. Find the area of S. Find the area of S. Okay, so nothing crazy, just top minus bottom. And maybe we highlight or shade S so we know exactly what we're looking for. So there's area S. I don't want to shade it too dark because I can peek ahead and see that I've got equilateral triangles coming up out of the page in a minute. But the first off is just area. So that would be, again, these little rectangles. We're going to add up the rectangles, sum the rectangles. Is this dx or dy? How are we slicing up the rectangles here? I mean, you could do it either way, but the way I drew that one, this is a dx problem. So dx means my limits need to be x things. So from 0 to 2, that was nice. They told us where it intersected here. From 0 to 2. Of top minus bottom. So the top is 4. And the bottom is this curve. And that curve is x squared. Now this didn't specify calculator or no calculator, and so our default for this section is use a calculator. This one wouldn't be too hard without a calculator, but let's use a calculator because B and C are going to be kind of weird. Let's see, it's been a weekend. What are the buttons I push to get to the integral stuff? Math 9. Our favorite combination of buttons. 0 to 2. Remember, I could have put this into y1 and y2, but this was a pretty simple one, so I'll just put it in right here. 4 minus x squared dx. That looks like it's like I could math frac that and change it into a fraction, but if it's a calculator problem, a decimal answer is fine. So.
Could you found like the area like as a box, and then subtracted like so you just did 4 times 2,
and then subtracted this area?
Yeah.
Yes. So the question was, could you have?
So much.
It feels like. Yeah, I mean, because we're used to finding areas down to the x-axis. Maybe that's what you're thinking. And so you could find the area of the box. 4 times 2 is 8, and then subtract 0 to 2 of x squared, and that should be the same thing. In fact, yeah, I can tell it's the same thing because the integral from 0 to 2 of 4 would be 8, because that's a height of 4 from 0 to 2. So there's like the maybe connection between the two. So yeah, and that's perfectly okay if you're like, whoa, why am I doing top minus bottom? Why don't I just find the area of something sort of normal and subtract it from 8? That's definitely okay, and it will get you the same answer. You also could have done this dy and done right minus left from 0 to 4, but most of the time we prefer dx. All right, part B. Region S is the base of a solid with equilateral triangles perpendicular to the x-axis. perpendicular to the x-axis. So that means it's a dx problem. And that means we have we have equilateral triangles coming up out of the page off of our region S. Again, maybe hard to visualize there. We've also been calling that length S. That's top minus bottom. Okay, so I'm going to add up all of the volumes. Again, memorize as little as possible here. I'm adding up all the volume slices. The slice is dx thick, and then I need the area of that cross section, and we're going from 0 to 2. Okay, so I need the area of a equilateral triangle. That's a new one, or at least, yeah, it's a new one. You got to memorize that formula. Does anybody remember what it is? Or you can flip back a page or two. Root 3 over 4 times s squared. I'm still not ready for the calculator yet because I've got to get a formula in there for s. So 0 to 2. I can move the root 3 over 4 out front because it's just a constant. S is top minus bottom, so that's 4 minus x squared squared dx. Again, because S, maybe I should have shown more work here. S is 4 minus x squared. So that's what goes in there. So it looks like a complicated formula, but you back up and all you're doing each time is adding up volume slices. So area times thickness, you need a formula for area, and then you need an x expression to stick in there for s, and now it looks really complicated, but it came from something relatively straightforward. We're just adding up all the triangle slices. Now we need to be careful when it comes to the calculator. Square root 3 divided by 4. Math 9, 0 to 2. And then I've got to square 4 minus x squared. So parentheses 4 minus x squared, close parentheses, squared dx. That happens a lot because all of the areas have something squared in them, have an s squared in them. So we're frequently putting stuff in parentheses and then squaring it. And so my answer then, pull out my key to make sure I'm right, 7.390. The answer key I have said the answer was 64 square root 3 over 15, which means somebody did it by hand. I'm not doing that. If it's multiple choice, I just type that, and this is what I just did. I typed that in the calculator to confirm that, yes, that is the right answer. Most of these will be with calculator. And again, even if your answers look fancy, then unfancy them by typing them in the calculator and seeing if it's the same thing you got. Okay, question C. They give us another picture to play with here. Region S is the base of a solid, so it's that same region. But now our equilateral triangle are perpendicular to the y-axis. So we got triangles coming up out of the page, but perpendicular to the y-axis. So again, we're going to add up. I'll start over again. We're going to add up all the volume slices. Now each slice is an area times the thickness. How thick are those slices? dy. We're slicing along the y-axis. So dy, which now means my limits need to be y limits. So from what to what? 0 to 4, because we're going up from 0 to 4 on the y-axis here. 0 to 4, root 3 over 4, s squared, dy. But I need to do some figuring on what s is. So I look at my picture, and my brain thinks, well, it's the right minus the left. That's one way to say it. The left is 0, so that's easy. But the right is this piece, which we said was y equals x squared. But I need to be careful because I need my expression to be I need it to be a y expression. I can't use x squared if I've got dy. Another way to phrase this is, this distance is x, but what does that x equal? Square root of y, because if I rearrange that, it's the square root of y. So I had to solve for x. I needed an x. I need it in terms of y, so I need x equals something to get in terms of y. So that distance is the square root of y. If you're ever not sure if you solved correctly, you can check a couple places. So you can be like, okay, if y is 0, what is s equal to? You can tell by looking. What's s equal to down here at y equals 0? How long is that side length? 0. Okay, that makes sense. If y is 4, then s should be 2, and square root of 4 is 2. So you can kind of check that, pick a couple points, and just kind of verify that that looks right. So root 3 over 4 from 0 to 4 of s squared dy. And actually that's an easy one to do by hand. Even if you go to the calculator for it, it might be best to do this part by hand. Square of the square root, you just get y. So that would be y squared over 2 from 0 to 4. Again, you've got a calculator. You should probably should use it. So that's root 3 over 8 times 4 squared is 16. So 2 square root of 3. Maybe I should make sure. Square root 3 over 4, math 9, 0 to 4. Oh, remember this is a dy problem, but your calculator doesn't know that. So if you want to just use the X button, it's fine. 3.46. Now, is that the same thing as 2 square root of 3? Yes, it is. So that one could have easily been a no calculator one, because it worked out nice. Again, lots of free response questions on the AP test look like that. They outline an area, they ask for the area of it, and then they start building things out of it. Number 6. The region enclosed by the graphs of y equals x squared, y equals 2x is the base of a solid. Okay. Again, I don't really need a calculator. I can tell by looking who's y equals x and who's y equals x squared. For the solid, each cross-section perpendicular to the y-axis. That's a major hint right there. Let's pause for a minute. What does that mean in terms of how I'm going to set this up if my slices are perpendicular to the y-axis? It's a dy problem. So already I can throw out C and D without going any further. So perpendicular to the y-axis, is a rectangle whose height is 5 times its base. So that base is, we'll just say it's S, and then the height is 5 times S. And then its thickness is dy. Okay, so we're adding up all the volumes. Their thickness is dy. We know it's a dy problem. So we'll go 0 to 4. Area of the cross section. And the thickness is dy. The cross section is, or excuse me, the area of the cross section is a rectangle. So that's just base times height. S times 5S. But I need to come figure out what S is. So on my picture, it is right minus left. Right minus left. But it's got to be a y thing. So the rightmost one is y equals x squared, which means x equals square root of y. And the left thing, so the distance there is, well, y equals x, so x equals y, so minus y. So square root y minus y. Uh-oh, why is that not one of my answer choices? What did I do wrong? Oh, because it was y equals 2x. So that means x equals y over 2. So y over 2, that was an easy fix. So yeah, question or answer A, right minus left squared times 5. It had to be dy. That's a great example of one where it was hard to get to the final answer, but it was hopefully easy to get to 2 of the answers. And again, if you make a 50 on the test, you're going to make a 3. Obviously, you don't want to be guessing 50-50 on every problem, but if you can get half of them right and guess 50-50 on the others, you'll make a 5. So, even if you feel like, oh, I don't understand this, like read every question carefully, pick out what you know, and maybe you can narrow it down and at least be guessing 50-50 on some of them rather than just, complete guessing on them. Okay, let's look at some questions from worksheets.